second part of the topic under equilibrium of forces, and we are going to start from condition for equilibrium of forces, especially under parallel coplanar forces. And if you look at the diagram, you see that we have 5 forces, 3 forces acting downward, then 2 upward. If you look at it very well, you see that we have, this is a let's assume that this was a metal rule with weight F2. Then we have 2 support, that is 2 upward forces. Then we have a force attached to it at this point, another force here. We now want to use it to state the condition under which this body will be in equilibrium. The first one is the downward forces here must be equal to upward forces. That is R1 plus R2, which is upward forces, must be equal to F1 plus F2 plus F3. And this is the first condition for parallel coplanar forces to be in equilibrium. That is, the sum or different sum of upward forces must be equal to downward forces. Then the second one that says the algebraic sum of clockwise moment must be equal to anti-clockwise moment. That one too is very easy to identify. What you just need to do, take your moment from one of the forces, especially the upward forces. Let's take our moment from here. Moment you are taking moment here, the force under this one is equal to 0. The moment of this one is equal to 0 because moment itself is force times perpendicular distance. Then perpendicular distance of this one is 0. So automatically this one will become 0. Then we are left with 1, 2, 3, 4 forces. Then how are you now going to identify the clockwise and anti-clockwise? What you just need to do, since you are taking moment from here, this one will look as if it's going like this. Any force, any downward force by this side will go like this. Any downward force by this side will come to this side. Then any upward force by this side will go in the opposite direction. Any upward force in this side will come like this. So let's use the arrow to indicate that we are taking our moment from here. You can take it from here as well. If you are taking moment from here, this one will go like this, which is anti-clockwise. Then this one will come like this, which is clockwise. This one will come like this, which is clockwise. Then this one will come like this, which is anti-clockwise. And don't forget, moment is force multiplied by perpendicular distance. Therefore, we are going to have F1 times perpendicular distance of F1 from where we are taking moment. That is x1 plus this one is anti-clockwise. The second anti-clockwise is this. That is R2 multiplied by the distance of R2. That is x4. So this anti-clockwise moment must be equal to clockwise. Then the clockwise is this. F2 times distance of F2 from here to here, that is x2, plus F3 times distance of F3 to where we are taking moment, which is what? X3, times x3. That's all. So the algebraic sum of anti-clockwise must be equal to clockwise, or algebraic sum of clockwise moment must be equal to anti-clockwise moment. So those are the 2 conditions for equilibrium of forces under parallel coplanar. I want you to take note of something under the condition for equilibrium of forces. The second one that we call algebraic sum of clockwise moment must be equal to algebraic sum of anti-clockwise moment. It's also called principle of moment. If you are asked to state principle of moment, you state that one only. But if you are asked to state condition for equilibrium of forces under parallel coplanar forces, you state the 2 together. Then the next subtopic is couple and its application. So when we say couple from the name, the normal way, our general understanding of couple is what? You believe husband and wife. But in this case, we are taking it to be two forces. They are equal. They are opposite each other. Two forces, equal, parallel, and opposite each other. But they are not acting along the same line or in the same sense. Take note, couple is a system of two forces. They are equal, they are parallel, they are opposite, but they are not acting in the same line of action. That is, their line of actions is different. So like when you have this, so if you have one force here, then another one here. So since their line of action is in the same, that they are not what? They are just two opposite forces. This is not couple. Their line of action must not be equal. So they are acting in the same, in different sense. So therefore couple as two equal, parallel, and opposite forces, not acting in the same sense. Now, if you have an object like this, let's have this. If you apply one force here, acting upward, then we have another one acting downward here. So if this one is 20 Newton, and this one too is also what? 20 Newton. So we call it couple in this case. So if distance between them is G, or let's say it's 20, 10 meter. So this is a couple because they are open. They have the same magnitude. That is, they are equal in magnitude. They are opposite. They are parallel, but they are not acting in the same sense. That is, their line of action is different. Then I want you to take note of something under this couple. They may ask you to find resultants of couple and moment of couple. So resultants of couple is always equal to 0. And because resultants of force acting in opposite direction, you are going to subtract. Because if one is positive, the other one will be negative. So in that case, this one will be 20 minus 20. The resultants of couple always equal to 0. But moment of couple is not equal to 0. Moment of couple is equal to the product of one force multiplied by the perpendicular distance between the two forces. Therefore, moment of couple P is equal to F1 or 20 multiplied by the distance between them, 10. So take note of the difference between moment of couple and resultants of couple. Moment of couple will give you value, but resultants of couple will always give you 0. Then application of couple. Where do you apply couple? And if you look at the tire, you apply couple there. Then the steering of the car is also what? Couple. The pedal of our bicycle is also couple. So that area that we apply couple, and at the end of the day, you see that the couple will result into what? Turning effect. Now the next subtopic is center of gravity. Center of gravity of a body. Center of gravity of a body. When we say center of gravity, we mean the point in a body where the resultant weight of the body act. And that we can still redefine it as where the body will be supported without what? Falling down, and that will make it to be in a state of equilibrium. So in that case, upward force will be equal to downward force. Then clockwise moment will be equal to anti-clockwise moment. Then how we now identifying? Like if you have a uniform meter rule, like this. If I'm having this one, I want to identify its center of gravity. That is, at what point will I support this object so that it will be in a state of equilibrium. You can see. So it means this is what is center of gravity. Then have center of gravity of some object, a meter rule, uniform meter rule, which is 100 centimeter. A center of gravity is at what? 50 centimeter. What of the circular object? The circular object, its own center of gravity will be at what? At the center of the circle. What of rectangular object? When we have rectangular object, its own center of gravity will be at what? The point of intersection of what? Of the diagonal. So that is that about center of gravity of a body. Then let's go to stability of body. Then under what condition? That will tell us the type of equilibrium. Under what condition can we say a body is stable or the body is not stable, that is unstable? Then what again? Neutral equilibrium. Therefore, a body can be stable or unstable. Is that body can be stable or unstable or neutral? You can say the body is stable if after receiving a slight displacement, the body returns back to its original position. Like if you have an object like this, the coal, let's have this, I have coal like this, then you have this one, then we have this. So let's say we have A, B, C. If you look at the diagram very well, if you just see this one or supply it with a slight displacement, it will just what? Shift and come back to its original position. So in that case, say this body is what? Stable. But the moment you just apply slight displacement to this one, what will happen? It will move away from its original position. So a body is said to be unstable if after receiving a slight displacement, it moves away from its original position. Then a body is said to be neutral if after receiving a slight displacement, a body comes to rest in its new position, not original position again, but new position. So these are the type of equilibrium. Then we can relate center of gravity of a body to stability of the body. Now let's look at these three diagrams. Look at this one. The center of gravity of this one is the point where this one can be supported without falling down is this. Then this one is here. Then this one is here. Then let's look at the height. That is, how does the height, the center of gravity of the body, relate with the stability of the body? See the height of this one to the ground. Look at the height of this one to the ground. Then look at the height of this one to the ground. You can see that this one is higher than what? This. Why this one is higher than this? It's telling us that the higher the center of gravity of a body to the ground, the lesser the stability of the body. This one is as what? The highest height. And is the most unstable object. I mean body, out of the three. This one is the lowest and the most stable one. This one is the next. So the higher the center of gravity of the body to the ground, the lesser the stability of the body. Then, center of gravity, that is how to relate center of, I think I saw one white question where they said we should relate center of gravity to the what? Stability of body. You can use the diagram, then you explain in detail. So that is the end of the topic for today.